Who's our guest on the Energy Nerd Show today?
Today we have Bill Moomaw, who has a long, distinguished career that I've been following since the 90s. Hi, Bill.
Hi, Jeannie.
Welcome to the show.
Thank you for having me.
How did you get into this climate, working on this climate problem?
I spent the first half of my career as a laboratory research scientist in chemistry, photochemistry, and the electronic structure of molecules and what happens when you shine light on them and how do they redistribute that energy. And sometimes they come apart and react with other things. And that turned out to be what was happening with the ozone layer, is that we were putting these chemicals up there that when they got above toward the top of the ozone layer is no longer absorbing the ultraviolet light that was protecting us and these molecules, and the molecules started breaking apart and releasing chlorine atoms into the atmosphere. And one chlorine atom can take down and destroy about 1,000 ozone molecules. So, and then it recycles and does it again. So I think the paper on that was published about 1972 or 3, something like that. And that was really fascinating. And I had in graduate school, I did work on what was basically solid state physics. But I found when I was bored with my very long, tedious measurements that took forever to get done with machines running to do it, I would go to the library and I found these wonderful research papers on everything from why smog in Los Angeles was caused by automobiles, with some very complicated chemistry worked out, why babies were being born with radioactive strontium in their bones because strontium acts like calcium, and we've been sending up, blowing up hundreds of atomic bombs, and don't worry about it. It's just so dilute, it's not going to matter. No concept in the physical science world of bioconcentration, that when A eats B and B eats C and D, so on and so forth, it basically is out there vacuuming up these trace things and concentrating them in living organisms.
Especially apex predators like humans.
Well, that's right. So anyway, I got interested in that. There wasn't any internet when I was in graduate school, but as graduate students, we had free copying privileges. So I started copying these articles for no reason other than I thought they were interesting. I might want to refer to them again someday. And by the time I got my PhD, I had 2 of these very large cardboard boxes full of articles. In 1969, I was a very young chemistry professor, and my department chair came to me and said, in December, this was just at the end of the semester, he said, only 2 students have signed up for your advanced thermodynamics course next semester. I don't think we ought to offer it. I was so relieved because it was going to be a really difficult course to teach, a lot of mathematics and so forth. And he said, would you ever consider teaching that environmental chemistry course or whatever you called it when we talked about this when we hired you? And I said, I was young and foolish. And I said, yes. I got my grades in and I spent Christmas vacation all of January putting together a course and a course syllabus, and based on these articles I had, and tried to figure out what a course would look like. And I walked into class on February 1st, 1970, and there were 75 students sitting there.
Wow.
And little did I know that April 22nd of 1970 was going to be the first Earth Day. I just had not focused on that part at all. I just focused on the interesting science that we had. But the next year I was better prepared. And I had an opportunity to sit in on a preparation meeting for the Stockholm Environment on the Human Environment, where all these scientists were there talking about climate change and all this stuff. And measurements of carbon dioxide in the atmosphere were only about 7 or 8 years old, but it showed this upward trend and this oscillation and all this amazing stuff. And I had an opportunity to be a congressional science fellow. Young scientists could apply to the American Association for the Advancement of Science. I was selected to be a science fellow. I got to Washington. I interviewed with various senators and Congress people, and I happened to be interviewed by Senator Dale Bumpers, a freshman senator, along with John Glenn and Gary Hart. He was the governor of Arkansas who defeated William Fulbright, and he was incredibly progressive and a delightful person. And he was the chair of the powerful committee on the upper atmosphere with oversight and no legislative authority on everything above 6 miles. It was the ozone issue. And that was just perfect because that was right in the field. I mean, it was in the general area I was studying, and it was a fascinating issue. And through that, I met all the atmospheric scientists, and that moved into climate change after we really did actually develop the first legislation to ban CFCs and spray cans. That was the piece legislation I spent a lot of time on. And I got to meet with the Representative DuPont every time he showed up, and with the scientists when they showed up. And it was just a wonderful experience.
So working on ozone, fixing the ozone layer was a great educational opportunity for you and for kind of the emerging environmental science community. And it's a stupendous success. I mean, compared to what we've been doing on global climate change, warming, it's like ozone, man, we fixed that, right?
We fixed that. In 10 years after we passed the law in the United States, we had an international agreement. We were going to cut it by half. And then we had amendments that got it down to zero for many of the substances. So in some ways, maybe it was unfortunate it was so successful, because then it got our expectations too high for things like climate change and other things. So
what do you think are the lessons for climate change in terms of science and policy? Is it just so much more difficult, or are there things to learn?
Well, what's different is the ozone issue only affected the chemical industry, and the chemical industry is based on science. And one of the witnesses that testified before the committee was the CEO of DuPont, and Senator Bumpers very cleverly asked him, what information would convince you that the ozone was being depleted by your substances? And he said, well, if it's valid science, we'd stop making it. Well, about 4 years later, the definitive evidence showed up. An experiment was done over Antarctica, which is where the biggest ozone hole was. And it found that wherever chlorine atoms were high, ozone was low, and vice versa. And so I sent that information to the senator, and still being the good staffer I was, I wrote the letter to him, the letter to the president of DuPont for him to send. And about 6 weeks later, DuPont announced that they were going to stop making chlorofluorocarbons. So, it was just, everything was aligned. The fossil fuel industry is engineering based. There's very little science there or respect for science beyond what the engineers need to engineer the product that they have. And it's just been very difficult to convince them that they're on the wrong track. DuPont was clever enough that they began researching alternatives after those hearings. We learned that later. And so they said, fine. And they had all this, they had these substitutes, and none of the Europeans had it, and none of the other chemical companies had it. So actually, it was a boon for them economically as well.
And I would think there are opportunities today in decarbonizing technology, clean energy, and so on for companies to make plenty of money if they innovate and kind of, think about the future rather than being stuck.
Right. Well, that's certainly true with the clean energy technologies. I'm more skeptical about technologies that will remove carbon dioxide from the atmosphere. I mean, just the scale of it is beyond our capabilities. I mean, you just can't build machines big enough to suck up enough atmosphere and get 0.04% of it removed, the carbon dioxide or the methane.
You've been working on net negative carbon. How would you define net negative carbon?
We talk about net carbon zero, meaning the difference between what we are putting in and what nature is taking out. Net positive means that what we're doing now, we're emitting more than nature takes out. Net negative carbon means that nature is taking out more than we put in. So we have to both put in less and nurture nature so that she can take out more. People don't realize it, but the increase in carbon dioxide every year in the atmosphere is less than half of what we put in. So we already have more than half the solution. And we didn't know where that was back when I started. So a lot of the research was, where is it going? And it seemed obvious that it had to be something like forests and oceans and maybe grasslands and where was it stored? We didn't know anything about soil carbon at that time. And it turned out that that's what it was. That in fact, the latest IPCC report finds that an amount equal to 31% of what we emit from our fossil fuels is removed by forests and other ecosystems on land, and over 90% of that is by forests. Okay, so forests are almost 30% of what is being removed, and oceans are 25%.
Is that by letting forests just leave them alone and let them do what they naturally do? Or is there some forestry information that...
We keep finding new ways to degrade the forests. And a paper came out last year that pointed out that the Holocene era, from the end of the last ice age till now, till yesterday, was maintained as a benign, relatively constant climate, which allowed human beings to shift from being nomadic hunters and gatherers prior and through the ice age to being able to settle down. I mean, agriculture, urbanization, civilization as we know it, all occurred because forests and oceans were sucking up carbon dioxide. Well, then we started in 1750, the beginning of the industrial era, burning fossil fuels and putting more carbon dioxide in the atmosphere. And it really took off, after 1900. I mean, and it accelerated even more after World War II. You can just look at the curve and it just starts leaping upward after that. I began about 15 years ago, maybe even 20 years ago, as the world was figuring out where all this carbon dioxide was going. Would there be any way to increase that? And what I discovered is we have cleared about a third of the world's forests. They're gone. And about a third of the extra carbon dioxide in the atmosphere comes from harvesting forests, degrading forests, and degrading soils and grasslands and other ecosystems. I guess we did it out of ignorance originally, but it is not helping the cause. So we've got that third equivalent on land up to that to put back in play. And so in 2019, I and two colleagues published the paper. I sent it to you on proforestation. Well, what's proforestation? Well, first of all, forestation means to grow a forest. Deforestation means to ungrow a forest. Reforestation means to plant trees where you've already removed a forest. And afforestation means to plant trees where there wasn't a forest before. So we were talking about planting trees. We're going to plant our way out of climate change. Well, we can't plant our way out of climate change because little trees don't grow fast enough to do that. If we wanted to meet the goals that we've set for ourselves, we really have to, supposedly be carbon neutral by 2050. And not only, nobody read this other part of that IPCC report, we need to be carbon neutral by 2050, but we have to have reduced our carbon dioxide emissions by 45% of 2005 levels by 2030. Because if we reach 2050 and we're carbon neutral, there'll be so much extra carbon dioxide in the atmosphere that the temperature is going to rise more than 1.5 degrees. So I realized that really the trees that were really growing the most were the ones that we already had. The maximum growth rate of forest, depending on the forest, is between, say, 50 and 125 years of age. All right, so kind of middle-aged forests. And old forests don't stop growing. They may not grow as fast as they did when they're 125 years, but when they're going from 200 to 220 years, they accumulate more per acre than does a new forest from 0 to 20 years, the same time period.
So they're still sequestering carbon.
They're still sequestering lots of carbon. And so there was no name for that. And so I went online and I said Latin and Greek prefixes and got all kinds of strange and wonderful possibilities. And I hit preforestation. No, it's not that. Oh, wait, what about proforestation? And so that's the term we chose. And it's absolutely infuriated the forestry industry. And a group of forestry scientists, those are people who figure out how to cut down trees continuously, highly criticized our work and said, there's no such term in forestry. And that's true because no forester ever thought about letting trees continue growing indefinitely. Right? So not surprising that they didn't have a term for it. In the meantime, in 2022, the IPCC had a wonderful endorsement of our work. It said that, furthermore, protecting existing natural forests is of primary importance in reducing greenhouse gas emissions, and restoration is not always possible. And it then cites our 2019 paper. So finally, I feel a little bit vindicated, taking a lot of flack, but it turns out that that's the one thing that can do it. And now people are talking about almost everything else. And since we're going to soar through zero net energy in 2050 anyway, and we'll do it by a lot, we have to find ways not to be carbon neutral, but to be carbon negative. That is, we need to have nature taking up more than we're emitting. And so we need to do that by doing two things. One is reduce what we're putting in. That's all technology stuff. And then we have to increase the ability of nature to take it out. And the most effective way to do that is with forests. We can do a bit of it by letting more of our existing forests continue to grow. And last summer, a paper came out that talked about our northeastern forests and our eastern forests in general are these middle-aged forests, which have absorbed about half of what they're capable. And many of them are in that fastest growing period. So, proforestation management, meaning letting them grow to achieve their potential for carbon accumulation and biological diversity, is the strategy, rather than sustainable forestry, which is growing a forest and figuring out the optimal time to cut it down so you can cut it down again in an economically reasonable time.
With proforestation, will we have enough wood for the other uses? Not for burning, of course, but the other things we like to use wood for?
Sure, we actually will, because it turns out that forests with the largest trees that are storing the most carbon. And for example, we did a study in Oregon that found that forests that had not been harvested in order to protect biodiversity, the largest 3% of trees held 42% of the carbon. And another study found in forests around the world that half the carbon in a so-called mature multi-age forest, which means it's not old growth, held half the carbon. So we don't have to allow all forests to keep growing, but we should choose carefully which ones that are more resilient, less likely to be damaged by fire and other things, and will grow the most in the coming decades, which are critical for halting the excessive climate change that we're seeing. There are ways of managing the forests that we are utilizing that are far less carbon intensive than the way we manage them now. And some foresters are beginning to recognize this. And I've had some very constructive conversations about having two types of forests. One are production forests managed so as to emit the least they can. So that means not burning it, among other things. And a second type of forests, which are planetary operational forests that are essential to the operation of the planet. And we don't know for sure where that the boundary is, but the comments most recently are that we probably need to set aside between 30 and 50% of each type of natural ecosystem for the planet.
I'm noticing, Bill, that you're not talking about capturing and sequestering carbon underground in deep geology or direct air, using electricity to direct air capture carbon. Do you want to elaborate on that?
Sure. In principle, those are all great ideas. The problem is carbon dioxide, as high as it is only 0.04% of the atmosphere. So it's 425 parts per million. Before we started putting in it was 280 parts per million. So it's increased by 50% since the beginning of the Industrial Revolution. And 1 part per million is something like 7.6 billion tons of carbon dioxide. Okay, last year, all of the 20 or so technical systems, and I realize this is at the beginning, were able to remove about 10,000 tons. Forests were removing something like 10 or more billion tons per year. Okay, so to me, it's no contest. I mean, and the cost and the energy input to separate out that tiny bit of carbon dioxide and then shove it and pipe it and then bury it is a fantasy for solving the problem. Jacobson at Stanford did an analysis of those approaches and did an analysis of doing something better, which is you put something on the stack of a coal plant or something and then remove the carbon dioxide. There, the concentrations are like 10% or something, right?
It'd be easier.
It's a lot easier, and you don't have to use nearly as much energy to do it. But even with that, his conclusion was that over 20 years, when you do the whole life cycle, you're only capturing net about 20% of the carbon dioxide that's emitted from that plant because of all the steps from capturing it and everything else.
So the forests have a head start, and they have the advantage in that those little green leafy solar energy collectors actually do grow on trees.
They do grow on trees. And it's really money saved growing on trees. That's what those little leaves are doing. And that doesn't count all the other benefits that forests provide. For example, since trees suck up water and evaporate it from their leaves, they reduce the risk of flooding. So one of the reasons the flooding is so horrific down in North Carolina is that so many of the forests there have been cleared off, replaced with, at best, plantations of trees that are harvested every 20 years to make wood pellets to burn in place of coal and ship to Europe to burn it, where it's counted as zero. You may have heard that England is off of coal. Isn't that wonderful? No mention of the fact it's because they're burning wood from North America instead, which emits more carbon dioxide per kilowatt hour of electricity than does coal.
So then if you're North Carolina, you are feeding climate change and realizing the effects of it in terms of flooding.
That's right. Yeah. I've been working with people down there who are concerned about this. And there's also an environmental justice issue because these wood pellet plants are all, guess where? Low-income communities of color. That's where they are, and I've met with a lot of those people, and I've seen the areas, and they showed me photos of the last flooding in their area where the water was up to the eaves of the church in the community, and that's nothing compared to what this must be now.
I know you've been involved in studying a lot of different solutions, and I know you've worked with a lot of different groups. So can you tell us something hopeful that's going on and kind of where this information has the most chance of impact?
Well, where I see the most hopeful, if you want to look at it at a wholesale kind of level, it's the way indigenous people manage their lands. In the tropical forests in the Amazon basin, the difference between the lands that are held by indigenous people and those that are being exploited is just like night and day. It's literally incredible how they are able to get their livelihoods directly from the land without burning it down or tearing it down or over-exploiting it or whatever it is. And of course, that's a combination of the fact that they have kept their population smaller and their value system is totally different. I've had the privilege the last 3 years engaging with an indigenous group in the Ecuadorian Amazon and a group of scientists. We've actually put out a joint declaration, which is kind of interesting, about our worldview. And you ask them, how is it that they decide what to do? And they said, well, we are an integral part of the living forest. And we wouldn't cut off our hand, so why would we just, damage the forest that supports us, sustains us? And, that really has caused me to realize that from the whole Western European tradition, rational tradition, basis of science, which we as Americans inherited, we didn't inherit it, we brought the people over here to inflict it on another continent. All of nature is a natural resource to be exploited for profit. The decision making is all in the economic system, totally ignoring the ecological functionality of these systems that have been supporting us and sustaining human beings forever that they've been human beings, at least. And we've totally failed to recognize that the forests and oceans and other ecosystems are essential components of the Earth's operating system. And so the very thing that provides us our oxygen, controls our carbon dioxide, reduces our flooding, provides us with many, many very useful materials. It's just astounding.
We started this conversation with kind of the beginnings of your career. So, Bill Moomaw in his 20s. And, it seemed like you kind of followed your authentic curiosity and looking for problems that were interesting and important, and, found a way to channel your energy and really contribute. And over the years, you've taught and mentored I think probably hundreds of students, maybe.
Thousands.
And I guess I'm wondering. This is all headed for a question, which is something like, what advice would you give to, someone today, where with that energy and idealism and wanting to fix the world, but also there's this need to make a living, and maybe you want to support a family and have a career. Like what would you tell these young people?
Well, what I've told them is, I said that if you go into any environmental field, you cannot expect to solve it, maybe even during your lifetime, but you'll have a lifetime of very satisfying contributory employment. It is a great way to make a living and help the living planet.
Very well said.
Thank you so much for all your work and inspiration over the years, and for being on the show to share this time today.
Thank you, and thank you for the work that you do at Synapse. It's just we need more. I mean, say you're examples, right? It hasn't been so bad. In fact, if it gets better, maybe we'll be out of a job, but that wouldn't be so bad for the planet, right?
That's our dream.
Right.
Thanks again.
Okay. Thank you. Bye.